Welcome to Pyvo, thanks for coming. I'll make it quick. Today is the last Pyvo before the last Pyvo before holidays, right? In July and August we'll meet in Horáček and barbecue again. And today's speaker is Tomáš from CVSS, and he will tell us something about framework that can help to discover and rate vulnerabilities in your Python projects, right?
Yes, exactly. Python or any other.
Okay.
Right.
Sure.
So the topic of my talk today will be a common vulnerability scoring system, or CVSS in short. I will start talking a bit about me. Do you have a clicker presenter? Okay. My name is Tomáš Horáček. I am a Python developer in kiwi.com, where my main work is automation of booking. And I'm kind of interested in security. And won't work because these new laptops don't have full-size USB. So, okay, that's okay. I'm kind of interested in security, but what I mean by that is that I'm no expert in it, but I'm looking for a way to make the application secure with as little work as possible and as simply as possible. Okay, so what's CVSS? CVSS is the common vulnerability scoring system, and it provides a way to capture the principal characteristics of vulnerability and produce numerical score reflecting its severity. Okay, now identify your keyboard. This is not a keyboard.
It has buttons.
But it cannot be identified. Okay, yeah, because it's not a keyboard. Japanese answer no, I don't. Go away. Sorry.
No worries.
Does it work now? Yes. Hey, perfect.
Also, if you want to start again, we can cut it.
It's okay.
Okay.
Now that you know what CVSS is, we can. Do you have any questions? Thank you. I told them to laugh, so it's fine. Well, I would like to go through the parts of its definition with you, and maybe that way we can all understand what it's about. So let's start with talking about what is a vulnerability in software. It is basically a weakness or a hole that an attacker can use to damage you or to exploit something in your system. I have a list of OWASP 10. That's a list of the most common and most dangerous vulnerabilities that can happen. You have, for example, broken access control, some injections, bad settings, old libraries, and so on. So a vulnerability is a way for the attacker to attack you. You might imagine your application to look like this, right? So it is closed. It's not perfect, but maybe you don't work for the military, so you don't really care. You want your users to work a certain way, so say please close it, and you expect, okay, some holes, but it's probably fine. Well, but the attacker might know the bigger picture and just go around, and this is a vulnerability. You might not know about it, but the attackers can exploit it and gain access to your system. So that's a vulnerability. And CVSS describes this vulnerability. And it describes it in three categories. That's a base category, temporal category, and environmental category. So I will talk about these categories now. The first one are the base characteristics. So how can we describe a vulnerability in a way that doesn't change, and it describes not the vulnerability, but what it's like. So, for example, the first part of the description is the attack vector. How far the attacker needs to be to attack you. So can I just go here and use the internet to attack you, or do I need to sneak into your office at night and swipe some keyboard or click on your keyboard or something? Second one is attack complexity. So can I do the attack anytime I want, or are there some conditions that need to be present? For example, do you have to forget to log yourself off or something like that, or you have a bad setting or others? Then there are privileges required. If it's none, it means I don't need any account. I don't need to be part of your company or anything. High, on the other hand, would be, for example, I'm an admin, and the vulnerability allows me to become a super admin, for example, or I need or I cannot destroy everything even though I shouldn't. So that's privileges required. User interaction. Am I the only one as an attacker who needs to be present to do the attack, or do I need someone else to help me? For example, do I need someone to click on a link or to accept something? If a user interaction is required, of course, it's less serious. Then we have scope. If I use the vulnerability, will I attack only on the part of the system that I'm attacking, or do I gain access to other parts as well? And finally, the impact metrics, and that's what am I actually attacking? Can I steal your data, or can I damage your data? Can I turn off your service, turn off your website, and so on? So these are the base characteristics of a vulnerability. How we can describe a hole in your system. How far do I have to be? How difficult it is, and what can I actually do with the vulnerability. The second category are temporal characteristics, and these change over time. So first one is exploit code maturity, and it says how easy it is to perform the attack right now. So maybe if the attack is very new, or the vulnerability is very new, no one performed it yet, maybe we think it might be possible, but no one really proved it. But in few months from now, I could just download the code from the internet and perform it and not even know about it. And I wouldn't need to know the details. The second one is remediation level. Is there a fix for that? Or can I turn it off? So a new vulnerability will probably not have a fix yet, but with time it might be fixed, and I just need to update dependency to fix it. And finally, how well known is the vulnerability? Am I the only one who knows about it, or can I search YouTube and some kid from China will tell me how to use the vulnerability? So these are temporal, and these change over time. And finally, we have environmental. These are a bit similar to the base, but they are specific for you. For example, we have the attack vector here. So the vulnerability might be network by default. It can be accessed by internet, but if your system is offline, then it can't be accessed by internet. So of course, for you, it will not be that serious. Then the impact, how it can impact you specifically. And impact modifiers is how bad it is for you. So these are a bit similar, but if the impact is confidentiality, so they can steal your data, that's bad, but if your data is already public and you don't store any private information, it's not that bad. If the attack allows the attacker to turn your website off for 10 hours, that's bad. But if you have a backup that grows automatically, it's actually not that serious for you specifically. So everyone might have different environmental characteristics. So these are the principal characteristics. Do you have any questions for that? Okay.
Yeah, what's the difference between the on the fixes, one side back, the remediation level, not defined and unavailable? What's the difference?
Okay, not defined is the default. When you are lazy, you don't fill it in, and unavailable is you know that there is no way to fix it right now.
Does it make it worse?
No, unavailable is worse. Not defined doesn't change the calculation that I will talk about later. Unavailable says it cannot be fixed. Not defined is we don't know, for example, or we didn't fill it in. So unavailable is worse. Unavailable, you are saying this cannot be fixed right now. Okay, thanks for the question. And the last part of the definition I want to talk about is produce a numerical score. So the CVSS uses the principal characteristics to describe the vulnerability and then gives you a number from 0 to 10. It uses some calculation that I won't go into deep, but first it takes the exploit impact or the base metrics, calculates the exploit impact. Then if you define the temper metrics, and that's what the question was about, you don't need to define it because it is optional. It changes the score. Then if you define environmental, it changes the score again, and at the end it gives you a score and some vector that defines the characteristics. The score is a float number from 0 to 10, and then it can be translated into none, low, medium, high, or critical. So maybe you saw one of these words when looking at the report of a vulnerability. And everything above 8 should be solved immediately. Ideally, mediums, maybe lows are often just lows. And this is important because you may have a lot of vulnerabilities in your system and you don't have time to fix them all. And some of them are not even worth fixing right now. Alright, so now I hope you understand the definition. So basically, CVSS is a way to describe a vulnerability and give it a score from 0 to 10. I will use an example from Java. That's the log4j vulnerability. Anyone heard about it? Yeah. If you look at the database and we can see some information about it. Let's start with the description. Okay, Apache log4j, some version, blah blah blah. Features used in configuration, log, messages, parameters, LDAP something, execution something. Yeah. Now I finally understand this meme, why it's so bad. There are much longer articles and videos that will explain it into a lot of details, but this isn't telling me much. And if I need to explain why it is so bad, it will take a lot of time. So maybe let's look at the CVSS. It says this is the vector over here. So this is the base characteristics of this specific vulnerability defined here. Attack vector is network, and we have the other values. In the middle we see the base score 10 critical, and it's black, so it's probably very bad. Okay, we are getting somewhere. If we click on that button, we'll get to a website like this, and this is a calculator for the CVSS. And we can see attack vector by network. It's pretty simple to do, you can do it anytime. You don't need any account, any privileges. You don't need any user interaction, you can do it on your own. You can do almost everything, and you can destroy data, steal data, you can switch off the application, you can destroy everything. And log4j was used in almost every Java application in the world. So yeah, that was very bad. So how can you detect vulnerabilities in your system? There are two ways. First, you can use some tools to scan your dependencies, and second, it's better than using tools is to automate the scanning. So this is my first live demo, and hopefully it works. So I need to switch this like this, mirror. All right. So I have a simple app. Put this away. I have a simple Python app that I can use to download XKCD comics. Right. Sorry?
Can you zoom in a bit?
Yeah, okay. Right, so I can use the application in Python to download XKCD comics.
Yay!
Impressive. That's security XKCD, right? And if I can make it larger, I will. And I can use a Python tool called safety to check the requirements. Okay, this is a small app, it doesn't have a lot of them. And it gives me a report like this. Safety, I'm using the free license, so it's not very in-depth. And there are also other tools you can use. the similar tools exist for not just Python, but for example, in JavaScript, npm will give you a list of vulnerabilities on default every time you install. And I can see I have 2 vulnerabilities here. If I click on this link, it will guide me to another database, and I can see it's high, 7.5. Okay, maybe I should do something about it. This is a way you can use to manually check for the vulnerabilities, but even better is to use automation. So this is the GitHub repository for that, and I can use Dependabot here, and it will give me a list of the vulnerabilities. It even shows free, so it's better, I guess. And I can list here them and so on. It's actually very simple to set up for GitHub. There is just one button that you click and it works. Unless it doesn't, and then you spend 10 hours or more fixing it, but that's how it is. For a small application like this, it's pretty simple, but if you look, for example, at the security overview of TensorFlow, it's 43 pages of vulnerabilities. Most of them low severity, so it says, okay, it's not that bad because low severity can be ignored most of the time. But the fix for those would be most of the time to update the library, if a fix is available. Okay, so that's my first demo, and it went well, I think. And let's continue. Okay. So you can see that there are vulnerabilities everywhere, and we should be careful about them. Now, how can we calculate CVSS for our vulnerabilities? Let's use an example of SQL injection. I believe almost all of you will know what it is, but in short, you have a form here where you log in. And if you put in password and name and password, it will fill in directly into an SQL query the name and the password. Okay, works fine. But what if I don't put in a password, but I will put in a query like this? So I'm closing the string and saying or 1 equals 1, which is always 2. And now I can log into the database without any password. I could also put in delete or some other things. Then the second demo. And we will try to calculate this together. So I will, what have I done? Oh no, I clicked the wrong thing. I don't understand. And we will use the calculator to calculate the CVSS. This is an online tool that you can use for free. So can anyone tell me what will be the attack vector for this? It's a web application and there is a login form available and I can use the SQL injection to get in. So will it be network, adjacent network, so local Wi-Fi, local or physical?
Network.
Yeah, it's network, it's by the internet. Attack complexity, can I do it anytime or is there some prerequisition that needs to be true? Anytime, yeah. Maybe if the website is down, but we don't want that. Which it will soon be. Privilege is required. Do I need an account? Do I need to be part of the company? No. Do I need anyone else to help me with it? No. Do I damage anything else but the form or the database? I can damage or steal all the data and damage the whole website. Can I steal some sensitive data?
Yes. Yep.
Can I damage some data?
Yep.
And can I turn the page down or can I destroy it?
Yes.
Yeah. All right. So we are getting to 10. We already saw this today. Okay. Now this would be a bit different if it wasn't, for example, a login form, but an internal form, for example, for an admin. So let's say that it's not for logging in, but for getting some unimportant data like, I don't know, when do people go for lunch or whatever. Then I can still do it by network, okay. The complexity is similar, but I need high privileges. I already need to be an admin. But maybe I don't have that much power to delete it, okay? I can only read. so maybe low. I don't need any user interaction. I don't damage anything else. I only see information I shouldn't, and I already could see the data before, but now I can damage it and I don't destroy the application. And you can see that the CVSS changes here according to this. We can also change the temporal score metrics. So let's say that we already have code that can do the attack. There is no workaround, even though SQL injection is very easy to fix with prepared statements, and everyone knows about it. Okay, and that changes the temporal score, which changes the overall score, right? And if I, for example, said that I have the same application, but I have a VPN or a firewall, and no one from the internet can get in, I can say adjacent network, and it will change the score as well. So this is a way how you can calculate the CVSS for a vulnerability in your software when you see something that's wrong. Any questions for this?
I have a question. So, like, how do you measure these when this is something novel, like something nobody has ever seen before? Like, how can you be sure that this is exactly how the exploit would work? Like, maybe you've missed something. Maybe you just like, is there a way to, you know, put in uncertainty about something?
Yeah. Well, you can say undefined, not for the base core metrics, but for the others. And that's a point I will get to soon. People do make mistakes with those a lot. Actually, more than 50%. There was a study, and they found out that more than 50% is 4 points off. So it's
In which
people any random, like I guess 2 points down or 2 points up, which can change the critical, which can be the difference between critical and high, for example. So people are pretty bad at scoring this, but we can be like it's a more problem with, I would say, smaller libraries or not that important exploits, but something that's very big there will be a lot of eyes on it, and so that's not that bad. But if you don't know, maybe you might be more cautious and say like the worst case, or you ask someone else, and he might help you with that. Also, there are nice tutorials and manuals how to fill it in. Even some cases like and examples, so you can use that.
Okay, makes sense.
All right, so that's the end of the second demo. And worked. So I will end with the challenges with CVSS, which I already started. It doesn't always account for context. It just focuses on the single vulnerability and doesn't look around, which can produce incorrect or not very good data. More importantly, it doesn't account for material consequences. So if the vulnerability is in a program that downloads XKCD images, it's not that bad when it flies an airplane or when it's used in a hospital. So this is not good in this way. If you use the automation to monitor your libraries, it will detect vulnerabilities in or old libraries in code that is not, for example, shipped to the customer in tests or features that you don't even use. So that is another way why you can have some vulnerability, but say, oh, it's okay because it's just in tests. It can't break anything. And as I said already, incorrect scoring, a lot of these scores are just wrong. Right, so that's all. Do you have any questions for me?
I have one
Sure.
question. So, like, how do you determine that the vulnerability warrants a disclosure? Like, I can imagine, like, it may be the case that you don't want to publish it immediately sometimes?
I'm not really sure about it, but I think there are like some laws that you need to disclose it in certain time. Or someone will tell you, hey, I know about this vulnerability and fix it, or I will let everyone know. So you might not have a choice, and big corporations
I'm not sure if
disclose
it's a
it.
law. I think it's more like a
Or
yeah.
yeah, maybe for like some state, like if the state.
Well, it
maybe,
definitely isn't for them. I'm pretty sure certain they are not publishing. Would they? miss out.
Yeah, but for example, Microsoft and all the big corporations publish almost everything they find, and it's often because they want people to upgrade. If you fix the vulnerability, you don't want people to use the old version. So that's often the case. So almost all the time. And I think I read somewhere that like maybe a rule or maybe a law in some countries. that
Because
they
I
want to
can imagine like
close
when you publish something that there's a security hole, I can imagine like it basically opens the door, right? Like, and not everybody, nobody, almost nobody in the grand scheme of things upgrades, right? It's basically like the exception, not a rule. So I can imagine like in some cases, you may want to keep it quiet until you are at least sure you've upgraded everything.
Yes, and
Well,
that's why big companies force you to upgrade.
I would expect that this code would be published separately from the CVE behind it, and the CVEs are kept secret until the fix is in place.
Yeah,
And
that's
the
kind of
most-
what I'm
Very,
thinking.
very often it's
Seriously.
published just with together with the fix in change notes, for example.
Yeah.
Or only without details. It's published that we have vulnerability, we are working on that, and without details.
Yeah.
Or like that.
But then
Yeah.
again, you have to take them at their word. Sorry.
It's okay, like those companies who wants to know about their vulnerabilities can offer a price for you showing them that they have the vulnerability. Like, yeah.
Yeah, like in Kiwi, we have a bug bounty program that you can join, and if you find a particular vulnerability and be the first, you can earn money. And then, of course, we will be forced to disclose it, I guess, or fix it at least. We don't ship the software, so we don't need to.
So in the end, you don't really
code like
do have the rule, you can have a motivation.
But the CVSS, if you are creating an application like, if you are creating a library, you will need to, or you should, and it's used by many people, you will want to create a CVSS core, or someone will create it for you and report it anyway. But if it's internal, you can use it for privatization. You don't need to disclose it outside of the company, but you say, oh, there is level 10 critical vulnerability, okay, let's wake someone up to fix it, because we don't want it here. Right? And one more slide, we have open item positions, so we will be happy if you like me and my colleagues over there, you can join us. Right? So that's all for me.
Could you pull it back to the previous slide? I need to
With
think.
the reporting one? Yeah, if
Yeah.
you just search Kiriko security about
You know, I'm lazy. I want to take the first picture.
How much is the reward?
Depends.
I don't know, there are
Depends on the
details,
CVSS score.
there are details in the accounting program, you can see it on the website. Right? Okay, so that's all from me, thank you for your attention.
Thank you, Tomáš. Is there anyone who would like to do a lightning talk?